What you want to do at the beginning of this problem is take those two equations that they give us, enter those into your graphing calculator, because we're going to need to calculate this very important intersection point right there, because it just calls that capital B and we don't know what that is. So I have those two functions entered into my calculator already. And when we graph it, it looks like that. You could zoom in on that a little bit. You could change the window to get to open up a little bit. But all I need this for, I mean, if you didn't know which is your top curve, which is your bottom curve, you could hit the trace button, identify the top curve, move the arrows to see what the bottom curve is. But you really just need it to get this intersection point there. I don't really need to zoom in because I can kind of see where that intersection point's at. And so let's calculate that real quick. So we'll hit second trace, second calculate. We're going to hit number 5 where it says intersection point. And then for intersection point, as long as I got my cursor near there, I could just hit enter 3 times. It switches it to the other curve and guesses for us. And then we get this 0.782 number that we're going to use through the entire problem. Now, you know, for part A, it just says find the area between the two curves. That's our easy top curve minus bottom curve right there. So that's just, and then you're going to use the X's left to right that take you across your bounded area. So we're going to do the Math 9 feature on the calculator. And I already have my F and G as my Y1 and my Y2, so I can just do this very quickly. So I'm going to go alpha trace. There's my Y1 minus alpha trace. There's my Y2. So there's my F of X minus G of X. And you need to show your integral setup like we have right here, and then go to the calculator and get that answer there around the 3 decimal places. Now, letter B is talking about H is the vertical distance between the two graphs. You know, if you want to measure the distance between two curves there, it's just going to be top minus bottom. So H is top minus bottom, which is going to be F minus G. And then wants to know is H increasing or decreasing. You know how we do that. We evaluate the derivative at that point and determine if that derivative is positive or negative. So the H is the distance between the two curves. So you're just going to subtract them. And we need to do the derivative. But luckily, this is a calculator problem, so we can do the Math 8 feature. It'll take that derivative for us. That's just F minus G. So again, it's just going to be the Y1 minus the Y2. And this is at that particular value of negative 0.5. And it gives us this negative 0.600. And you can use negative 0.6 on that. That's fine. Check the rubric on there since you saw those zeros. But notice since the derivative is negative, that means the H function is decreasing. So you got to have the number, use the calculator to practice that. And then you got to mention that H is decreasing since the H prime at that number is negative right there. So make sure you're justifying your answers really good. All right, letter C is actually a pretty straightforward cross-section problem, right? You see the phrase cross-sections in there, and it says perpendicular to the x-axis are squares, find the volume. So we're going to do the find volume using cross-sections. You know, when you see perpendicular to the x-axis, that's when we typically just draw our S perpendicular to that x-axis, and then we find the length of that S. It's just going to be top curve minus the bottom curve, the top Y minus the bottom Y. And so that's where I got my S equals F minus G again. And then remember when you do the volume by cross sections, you integrate the area of your cross section shape. And so since they tell us we got easy squares for the cross sections, you're going to integrate the area of a square, which is S squared. So you're going to integrate F minus G squared between that -2 and that 0.782 number. All right, so we could do that together real quick. We're going to do Math 9, -2, 0.782. And then when I square something, I think I'm going to need another parentheses here. So I'm going to do a parentheses and then my Y1 minus Y2. Close the parentheses, then I can square it. So there's my F minus G squared. You got to remember to put that squared up in there. And then that should calculate that volume for us at 5.340 number there. So make sure we're studying those cross sections, getting those easy setups down. And then letter D says a vertical line travels from left to right. The vertical line is moving at a constant rate of 7 units per second. So we got this vertical line moving. So if the vertical line is like X equals a number, and then that keeps changing right there. And they tell us how fast that X is changing. So that means like the dx dt is going to be equal to 7 there. Find the rate of change of the area. All right, so rate of change of the area, that's the derivative of the area. We're talking with respect to time here. It tells us with respect to time. So we're going to find the dA dt. when this x is equal to this negative 0.5. Okay, now it says the area of the cross section above. Now remember the area, when you do cross section volume, you integrate the area of the cross section shape, and then that dx or dy is what's adding that third dimension and turning it into a volume for us there, okay? So, and then you're adding up a bunch of areas as you radiate throughout that shape. But if you're just talking the area part, so again, that s was f minus g, so the area is the f minus g squared. That's what we're sticking with right there. That's what the a is equal to, is just your area part, which is f minus g squared. Now, we're supposed to take the derivative of that with respect to time. So like without a calculator, I have a power here. I can multiply by the power, leave the inside alone, decrease the power by 1, times by the derivative of the inside. And if you're taking the derivative of x's, you got to tag on a dxet at the end of all of that. We don't have to take this derivative by ourselves because it's on the calculator part of the test, but I need to take the derivative of this. And so that's my a function. The squared is part of my a function. And so I need to take the derivative of that. So that's already in there as my y1 and my y2. So I can do the derivative of that using the math 8 feature at that point. That'll take the derivative for me. And then we got to times it. We just got to remember to times it by the dx dt. So I can do math 8. And then in here, so I'm going to do a parentheses. And then again, we're going to do the y2 minus y1 real quick, because there's my f. There's my g, close the parentheses and square it. So that represents my area function that I want to take the derivative of at this negative 0.5 number. And I'm getting this giant number in right here. Now you're not going to round it and then times it by 7. You're just going to leave it in there, times it by 7, and you're going to get this negative 9.272 number. They didn't really ask for units on that, but it's how fast, if they did ever ask for units, it's how fast an area is changing. So it's like square units per second on there. So just make sure you get those little details down with the cross sections, and then practice stuff like this with this letter D. Is a little tricky, but once we come up with that, we can easily kind of figure the rest out and try and get better and better at those problems there. Hooded sweatshirt.